Hello, welcome to the January 2022 paper 2. This one is not regional, so not regional. And I think this is a tough paper. So if you've worked through this and you're using this to mark it, yeah, it's a tough paper. It starts off with question 16a. This is for foundation only, but I'm just going to go through it quickly. So x times 2x is 2x squared. Take away 3x plus 14x plus 7 minus 5. And then you collect these like terms. So only 2x squared, so that's not going to change. We've got plus 11x and then plus 2. Now this is where we start to get some topics on the higher. I'm gonna use the grid method because again this is nasty. It's a nasty paper, and it started off with something that's a bit nastier than normal because normally we'll see the y at the front, but we've got it there. It's all going to be fine though. We can work this out. So 2 times y is 2y. 2 times 4 is 8. Minus y times y is going to be minus y squared. And then minus y times 4 is minus 4y. So that gives us minus y squared. Minus 4y and 2y make minus 2y. And then plus 8 at the end. Okay, sorted. Factorise fully. So first of all, what number can we divide both of those by? Well, it's going to be 5. Then we can divide both of those two terms by the lowest number on the of the indice of the b, so b cubed. And then the lowest, I guess, would be on the left-hand side, which is just c. We now divide those two terms by the term on the outside. So 15 divided by 5 is 3. B to the 5 divided by b cubed is b squared. And then c divided by c is 1. Okay, take away 35 divided by 5 is 7. B cubed divided by b cubed is 1. C to the 9 divided by c is c to the 8, and that is it factorised. We know it's fully factorised because inside the bracket there's no common factors. We can't continue to divide that. Okay, question 2, show that. So to any of my year 11s, this is why we keep doing fractions work with our calculator. So we're going to first of all convert into improper fractions. 6 times 4, 24. Add the 3 is 27. So 27 over 4. Divide by 2 times 7, 14. Add the 4 is 18. 18 over 7. And I'm not going to look at the equal to bit at all. I'm not going to change that. Okay, so keep, change, flip. Keep, change that for a times by, flip the other number. Now, before I start multiplying, I can cross divide here. 27 and 18 will both divide by 9. So I can start to cancel this as I go. So that's going to be a 3 and that's going to be a 2, which makes the multiplication a lot easier. 3 times 7, 21. 4 times 2 is 8. 8's into 21, going twice with a remainder of 5, and we've done it. So that's a nasty one as well. This paper's tricky. Question 3, similarity. This doesn't come up every year, but effectively you've got two shapes. One is an enlargement of the other. And what we can see from the 4 and the 12 is to get from one shape to the other, we've got to multiply by 3. It wants us to calculate the length of BC. So because we're going from big to small, rather than multiply, we're going to divide. So 16.5 divided by 3 is then going to get us the value. So 16.5 divided by 3, 5.5. So the value of BC is 5.5. Then it says write down an expression for y, so y equals, in terms of x. Well, in order to get y, we need to multiply x by 3, so y equals 3x. And that's that bit done. Question 4, each side of a regular octagon has a length of 18 millimeters, correct to the nearest 0.5 millimeters. Write down the lower bound for the length of each side of the octagon. So because it's to the nearest 0.5, the smallest it can be is 17.5, because that would round up to, no, this is not correct. Not correct. Get rid. So to the nearest 0.5 means it could be 18. So it could be 18. Could be 17.5, could be 18.5. So there are values. So what we do with our bound is we divide it by 2, which is 0.25. Then we add it on to get the upper bound, which is 18.25, but that's not what we're looking for. We're looking to subtract, and it would be 17.75. Nearly made a boo-boo there. Really glad I took my time to look at it. Write down the upper bound for the length of each side of the octagon. Oh, same thing. Oh, we've already worked it out. 18.25. Perfect. Always wonder why have you used a whole page just for those 2 marks, but there we go. It is what it is. Question 4 is done. Right, question 5. I had a sneaky look at this. I don't have the technology to do this perfectly, but the scale diagram shows the position of a map on a map of house A. And we're pointing up north, and the scale is 1 centimetre to 200 metres. House A is on a bearing of 110 from A. The distance is 700 metres. So what you need to do first of all, right, 700, divide it by 200, and that's going to tell you how many centimetres it is. It's 3.5. 3.5 centimetres is the length you're going to draw. And then you need to get your protractor out. So that's 90. We measure these from north, and 110 is probably about there, using a ruler, of course, and it needs to be 110 degrees, and it needs to be 3.5 centimetres. Right, part B, write down the scale of the map in form 1 to n. So at the moment, it's 1 to 200 metres. We then need to convert that into centimetres by multiplying by 100, and it's 1 to 20,000. Okay, question 6, then we're going to pause for the next part because this is quite a bit of a big paper, so there's 11 crossover questions rather than 10. So a bag contains only pink, white, green, and red sweets. The table gives each of the probabilities that when a sweet is taken from random from the bag, the sweet will be green or it'll be red. The ratio of pink sweets to white is 2 to 1. There are 28 red sweets in the bag. Work out how many white ones there are. Well, first of all, we need the probability. So 0.2 plus 0.35 is 0.55. From there, we do 1 minus 0.55, which gives us 0.45. Then we need to split this into the ratio. So 2 plus 1 is 3. 0.45 divided by 3 is equal to 0.15, meaning that pink is 0.15 and white is going to be 0.3, which is 2 lots of it. Okay, now we've got those probabilities. We have an amount, so there's an amount of sweets, and we'd multiply by 0.35 to work out how many red sweets there were, which is 28. So if I do 28 divided by 0.35, that's going to tell me how many sweets there are in the bag in total. 28 divided by 0.35 is 80. And then to work out the number of white sweets, it's going to be 80 times by 0.3, because that's the probability of getting a white sweet, so it's 24 sweets. Okay, I will see you again for question 7. Looking forward to that, because I'm not sure how to break a number into a product of its primes using the CG50. So I will maybe have a little look around and see if I've got another calculator for that, because that'll make it easier. But I will, of course, I'll see you at the next video. Good luck for your exams. Spread the word of the channel. Get me loads of subscribers. Get me a load of watch hours. That'd really help grow the channel so I can help as many people as I can. And I'll see you at the next video. Bye-bye.